Okay, let us now get into the meat of this lecture sequence. Let us start by trying to understand how to build a digital gate. What I'm going to do is try to build up your intuition using an analogy. So let us say I have the following system. I have a reservoir of water, and what I'm going to do is connect it through a pipe to some output C. And what I'm going to do in the pipe is have to think of them as taps or faucets. Okay, so I have two controls here. Think of them as taps that are in series with each other. And let's take a look at what happens. Let me call them A and B. So how does this work? So suppose under what conditions do you have H2O, the water, at the output? Well, you get water at the output when both A and B are open. Okay, when I make both of them, set both of them into a state where they allow water to pass through, then C will contain water. If either of them is shut off, then there won't be any water in C. So I can write this into some kind of an equation in the following way. I can say if A is on and B is on, then C has water. But if both A and B are not on, then what I'm going to see happening is that C has no water. So if A is on and B is on, then C has water. But if either one of them is shut off, then C will have no water. So I'm going to use this insight to build an AND gate. Now think of the water here as your power supply. The water here, like the power supply, is going to, it's like a power supply, it's going to supply juice, and I'm going to have water flow here to the output only if both taps A and B are on. Okay, so I'm going to use this insight to build a AND gate. Okay, well that's pretty good. Let me give you some more, another example, and show you what I might do to build a OR gate. How might I get a OR function? Well, let me start with a similar sort of reservoir containing water. And then what I'll do in this case is, rather than connecting the switches in series, I'm going to have two pipes that connect in parallel in the following manner. So I have two branches, and I want to set up a little tap in each of them. I'm going to call them A and B. And my output here, as usual, I'm going to call C. So in this case, what do you see? In this case, you see C has water if either A or B is turned on. Okay, so this is a OR function. Okay, so in this case, if I turn either of the taps or faucets on, then my output has water. So now switching over to the electrical domain, let's convert to a electrical analogy. And so in this case, supposing I have some voltage source supplying a voltage V, and suppose in this situation, I set up two switches. Okay, let's call them A and B. So this is a switch. Okay, and this is a switch as well. I have a couple of switches, and what I'm going to do is, supposing I connect a bulb to my switch, and I complete the circuit here. Okay, so A and B are switches, and let's say C is the bulb turning on or off. So I have two switches, A and B. So in this case, I can write my little equation as follows. If A and B are turned on, then bulb C will turn on. But otherwise, if both A and B are not on, then bulb C will turn off. So this is a drawing from the same analogy with the little water reservoir. And so here, if I turn off either one of A or B, I won't have my bulb turning on. So this, I'm going to use this insight to build a AND gate. So notice that only when A and B are turned on, I'm going to have current that goes through the bulb. Okay, so I'm going to use that insight to build a gate. But notice that the key here with this logic was the concept of a switch. So I'm going to start by inventing a switch device. Okay, let's create a switch device, and then using this insight here, we are going to build a AND gate. and then we'll build other forms of gates as well.